Welcome to the Moog Complete Strut Assembly Design Consideration webinar. The material presented here has been supplied by Matt Hall, Product Engineer for Moog Complete Strut Assemblies. In this webinar, you'll learn the features engineered into Moog strut assemblies that sets them apart from the competition. I'd like to use this webinar as a tool to give you the information necessary to communicate the benefit of Moog Complete Strut Assemblies to our customers. As with control arms and axle half shafts, complete strut assemblies have increased in popularity as technicians look to save labor time and offer a complete module that will help restore the vehicle to like-new feel and performance customers expect. Moog complete strut assemblies have been a success due to the quality and problem-solving features, such as including the lower mounting hardware on top-selling SKUs. In certain regions, corrosion can cause the lower mounting hardware to freeze and break or be destroyed during service. To aid with installation, Moog includes the lower mounting hardware with over 30 high-volume part numbers. This can save time and money. In this section, we'll discuss the product design and performance features. To start, it's important to understand the terminology of the different components in a complete strut assembly. Starting from the left is the upper mount. The yellow piece under the upper mount is a bearing that allows the strut body to turn when the vehicle turns. Note that not all complete strut assemblies have bearings. Depending on a vehicle's steering system, it may not be necessary for the strut assembly to rotate. The bearing or upper mount sits on top of the upper spring seat. The upper spring seat provides a stable place for the coil spring to sit. Inside the coil spring, there's a jounce bumper and a dust boot. The dust boot covers the piston rod, which is a component of the shock absorber or strut. The bottom of the strut assembly is the lower clevis bracket. This lower mounting bracket varies in shape and style depending on the vehicle. Now that we're on the same page with terminology, I'd like to discuss the most important components of the complete strut assembly and how Moog carefully designs these components. What exactly is the function of a strut? There's a common misunderstanding that the strut is what supports a vehicle's weight. In fact, the spring is the component that supports the weight of the vehicle. Without a strut, a vehicle would bounce up and down until the spring naturally comes to rest. The main function of a strut is to stabilize the vehicle by dissipating the energy into heat through the hydraulics in the strut. The strut needs to dissipate this energy as efficiently as possible, which requires proper sealing. Keeping contaminants out of the strut tube and preventing the hydraulic oil and gas from leaking will ensure the strut will endure tough road conditions. There are many features in Moog struts that contribute to optimum performance. The main feature of Moog struts is the triple piston rod seal. The triple seal consists of an outer wiper seal, a main seal, and an inner PTFE buffer seal. The outer seal cleans the piston rod and prevents contaminants from entering the strut. The main seal is a one-piece molded design featuring twin seal lips. It optimizes sealing performance and durability. The inner PTFE buffer seal absorbs high-pressure fluid spikes caused by rough road impact and improves the efficiency of the main seal for longer seal life. Moog struts are nitrogen gas charged. Nitrogen gas prevents aeration in the hydraulic oil. It's important not to have air in the strut. Air can be compressed, but liquid cannot. Also, air interacting with hydraulic oil will cause the hydraulic fluid to foam, affecting the performance of the strut. It's important that debris not enter the seal cavity of the strut. This will lead to premature wear of both the main seal and the piston rod, causing the strut to leak hydraulic fluid. Fluid loss will lead to product failure. The main function of the coil spring is to support the weight of the vehicle and compensate for irregularities in road surfaces. Supporting the weight of the vehicle means the spring will maintain proper suspension height and is able to support added weight without sagging. Maintaining proper ride height is essential for precise handling of the vehicle. At Moog, we design the coil springs so they meet OE specifications for ride height while providing superior ride. By utilizing a variable spring rate, our springs can support extra weight in the vehicle, maintain OE ride height, and provide excellent ride and handling. coil springs are coated to provide a greater corrosion resistance. Upper mounts are essential to the function of a complete strut assembly. Upper mounts must fit the vehicle correctly, resist and insulate road forces, and allow for steering inputs. If not carefully designed, many aftermarket upper mounts will cause noise. Another important component of the upper mount is the studs, and the nuts should be OE quality. If not, nuts could strip when installing or removing them from the studs. Corrosion resistance is extremely important. Seen to the right is a corroded OE upper mount removed from a Dodge Stratus. With the correct design, this corrosion can be limited or prevented. The upper mounts are tested for 150,000 cycles to ensure durability and performance. It's important that metal components are protected. If not, they may corrode, which can lead to dynamic changes in a vehicle's alignment and, more severely, failure of the upper mount. All Moog strut assemblies are noise tested to catch any noise before production. Over the next few slides, we'll be discussing what differentiates Moog strut assemblies as a superior aftermarket solution. The topics will include coil springs, noise testing, rod structure, upper mount orientation, vehicle suspension height, problem-solving solutions, bushings, vehicle alignment, and steering components. Coil springs are one of the most critical components of the strut assembly, if not the most critical. A main factor in the coil spring design is the material used. It's important to use the best spring steel available so the spring doesn't fracture. As you can see on the left, this is a coil spring that broke during use. This spring was designed with weak spring steel to save cost. Because the spring material wasn't strong enough to handle the normal weight of the vehicle, the spring fractured and punctured the tire. Moog only uses the best spring steel available. We design our springs to provide a comfortable ride while having excellent durability. We coat our springs so that rust can't factor into a spring breaking. Our customers can be assured they won't experience a broken spring, which can leave them stranded or worse. Noise testing is one of the most critical steps in the design process for Moog complete strut assemblies. From our research, we found that about 37% of all issues with complete strut assemblies are noise-related. Many of these noise issues can be caught by simply noise testing prototypes. Moog's noise test equipment simulates extreme road conditions and, with a strict design requirement, allows us to design out noises prior to production. As a result of noise testing, issues can be reduced by as much as 80% versus competitors. These noises are usually caused by metal-to-metal contact between strut assembly components, and by eliminating this contact, we can increase strut assembly life by as much as 30%. All of this because Moog takes the extra step and time to noise test our product before production. An important and often overlooked design feature of complete strut assemblies is the piston rod structure. Other suppliers may use a weld-connected rod structure. As you can see on the screen, the threaded end of the piston rod is welded to the end of the rod. This significantly affects the concentricity of the rod. This may lead to wear on the upper mount and the piston rod. It decreases the strength of the complete strut assembly. Moog machines the piston rod as a one-piece unit so that no welding is required. This is much stronger and the concentricity of the rod is much better. Moog increases the service life of the strut by up to 20% just by using an integrated connection rod structure. The next topic I'd like to discuss is upper mount orientation. It's imperative that the upper mount be oriented correctly. If the upper mount is not oriented correctly, the customer won't be able to install the strut assembly into the strut tower. When this happens, the customer has to rotate the upper mount by hand, which can be extremely difficult. If the strut assembly doesn't incorporate a bearing, the only way to correct the upper mount orientation is to disassemble the strut assembly and reassemble. One of the best features about complete strut assemblies is the quick and easy installation. When the upper mount isn't oriented correctly, the installation is neither quick nor easy. The picture on the right shows how Moog ensures that the upper mount is correct every time. With this fixture, Moog can control the angle of the upper mount within 1 degree of accuracy. This is an important step during the design process that is not overlooked by Moog. Controlling the ride height of a vehicle is extremely important. Ride height can directly affect tire wear, wheel alignment, and stability control. A very popular and conventional way of measuring ride height is to measure from the bottom of the rim to the top of the wheel well. This can be an effective way of measuring ride height, but many OEMs specify ride height dimension by a different measuring procedure. Since Moog complete strut assemblies are designed for aftermarket vehicles, this procedure isn't sufficient. For example, the pictures on the right show how the ride height of a Dodge Charger was measured. Dodge specified the ride height measurement be taken from the ground to the bottom of the engine cradle. Using a specialty tool, we can easily and accurately measure vertical distance from the ground to any point under the vehicle. Moog captures the ride height data before and after prototypes are installed. Almost always the vehicles are not brand new, and the ride height could be lower than OEM specifications due to normal wear. There would be no way to verify if our complete strut assemblies meet OEM standards if we measured ride height like the guy on the left. Moog does not measure ride height this way. By measuring ride height the OEM specified way, we can ensure our strut assemblies will meet OEM ride height standards, saving our customers time and money. Vehicle age and/or environmental conditions can cause the lower strut mounting bolts to be rusted and difficult to remove. During the removal process, the bolt heads may become stripped or the nut or bolt heads may become rounded. If this occurs, they'll need to be replaced. This may slow down the repair job as sourcing new hardware may be time-consuming. In addition, while not required, installing new lower mounting hardware is recommended by many manufacturers when replacing ride control products. Not only do we supply lower mounting hardware, we identify other components that may be damaged during the removal of struts. For example, the gasket shown is used by Nissan to insulate the upper mount. We discovered that this gasket tore easily when removing the OE struts. Because of this, we decided it was necessary to provide the gasket with the Nissan strut assembly. These problem-solving solutions are just a few of the features that make Moog complete strut assemblies a superior product. Bushings may be overlooked during strut design. Moog designs bushings for long-lasting life. Opposed to other struts, Moog uses a stamped metal insert to protect the rubber bushing from corrosion and from walking out, as you can see in the pictures on the left. By properly designing our bushings, Moog struts are more durable than others. A properly aligned vehicle is imperative for vehicle performance. A properly designed strut assembly directly affects a vehicle's alignment of caster, camber, and toe. When a strut assembly has a steering arm welded to the strut, it's important that the steering arm has the correct orientation. If the orientation of the steering arm is incorrect, the vehicle will be misaligned, as you can see in this picture. The picture shows a real-life application of a steering arm being incorrect. The tires on both sides of the vehicle point outward. The vehicle is extremely unsafe to drive in this condition. The tow-out was so severe that the tie rod could not be adjusted enough to correct it. Moog takes the time to trial fit and design the strut assembly properly to ensure vehicle performance and safety. Complete strut assemblies may also directly affect the vehicle's steering system. In the example shown, the vehicle's tie rod end connects to a steering arm welded onto the strut body. A problem we found is that the steering arm hole has an incorrect taper. As you can see on the left, an incorrect taper doesn't allow the tie rod end to fit properly. The improper fit is so severe that the cotter pin can't be installed. Improper fit between steering components will lead to wear of the tie rod end and will cause loss of proper steering control. Moog inspects mating parts thoroughly in the design process. Mating component fit is validated throughout the trial fit process prior to production. This ensures correct fit between components for every application. We hope this webinar gave you the necessary tools to communicate the benefits of Moog complete strut assemblies to our customers. If you have any questions or concerns, please visit the Moog Problem Solver website for Did You Knows and other bulletins.